Once again, good evening, sir. Before going for the non-ferrous materials, we can at glance we can at glance the ferrous materials, key characteristics, common industrial applications. You can say mild steel, good balance, strength, ductility, rigidity. These are the at glance whatever the in the before slides we have discussed. At glance we have given all these types are ferrous metals, key characteristics as well as the common industrial applications. Already we have discussed, but at glance, good balance, strength, ductility, readily weldable, relatively low cost, and susceptible to rust. Where the construction structures usually is applications, automotive body panels, machinery parts, pipes, general fabrication, high carbon steel, very high tensile strength is there, good, and wear resistance less ductile, difficult to weld, cutting tools, springs, the bearings, high stress components, stainless steel, excellent corrosion resistance, high strength, good formability, high cost, whereas applications is kitchenware, surgical instruments, chemical processing equipment, food processing equipment, processing machinery. Coming to the cast iron, where we can say high compressive strength, good vibration, damping, poor tensile strength, difficult to machine, and engine blocks, machine bases, pipes, heavy duty machinery parts can be used by cast iron. Wrought iron, very ductile, good corrosion resistance, relatively soft, difficult to fabricate, decorative ironwork and handrails, and the ornamental gates like hardware and other things we can be used by wrought iron. Alloy steel, enhancer properties through added elements like nickel, chromium, manganese, tailored for specific applications, as we already discussed in the previous slides. High tensile strength, structural improvements, structural components, gears, axles, pressure vessels will be prepared as a from the ILR steels. Now coming to this non-ferrous materials, again I'm giving the previous slide. There are a large number of the ferrous metals covering every metal like lead, aluminum, copper, lead, nickel, tin, titanium, zinc, and copper alloys, bronze, and brass. Again, I'm giving here. And coming to this difference between the ferrous and non-ferrous, where we discussed earlier also, but at glance, we're giving because before going to the detail in non-ferrous, I will be exposed here also to easy recall the material. The ferrous metals contain iron, non-ferrous metals do not. Non-ferrous metals are rarer, more valuable and resistant to corrosion than ferrous metals. Ferrous and non-ferrous metals can be both recycled. Magnetic the iron in ferrous metals can separate from the iron. That's what here is magnetic properties by ferrous materials. Non-ferrous is not. Value is more in this and less in this case. Whereas resistance to corrosion is less here resistance to corrosion is more here because in this iron content is more. Recyclable, both can be recycled in the industries. Now detailing to the non-ferrous materials like for example, key points about non-ferrous, they do not contain iron. First point is. Then what it contains then? Whereas ferrous metal contain iron is the most percentage. Here they do not contain air, are not magnetic, number one. Number two, have good corrosion resistance because of iron is not there, are excellent conductors of electricity and heat, are often lighter in weight than ferrous materials, and are commonly used in applications where malleability and ease of fabrication. Malleable means easily it can bend, easily it can be uh, uh, do the what is called things whatever you want, materials and all. And fabrication are important. Examples: non-ferrous metals including aluminum, copper, zinc, lead, tin, gold. So these are the important. First point is they do not contain iron. The iron is not there because of not magnetic. And good corrosion resistance is there because of the iron is not there. Excellent conductors of electricity and heat also are often used than ferrous materials here. Further details here is non-ferrous metals or materials are any metal that do not contain a significant amount of iron and making them non-magnetic. Definitely, this is the one of the definition clearly defines that because of it does not contain iron, it becomes a non-magnetic. Magnetic property is not there for the non-ferrous materials. Corrosion properties: corrosion resistance, electrical conductivity, thermal conductivity, malleability, and lower density areas. Very important areas. One is the corrosion resistance due to their lack of iron. Non-ferrous metals generally have high resistance to corrosion to and rust also because the iron content is not there. Even is exposed to the water also in less time it will not be a corrosion like a ferrous materials. Electrical conductivity. Many non-ferrous metals are excellent conductors of electricity. And also the thermal conductivity, they also tend to good conductors of heat because it withstands to the higher temperatures also. Keeping examples are very important here is. These are the examples: aluminum, copper, lead, nickel, tin. While studying the non-ferrous, these are the keep in mind. Definitely it will be helpful for the recalling the topic series. Coming to the malleability is, these metals are often malleable and ductile, meaning they can be easily shaped and formed. That's what I told you. No? It can be easily bendable. It can be easily with less high heat. It will be easy to prepare the various shapes whichever you want. Okay, sir. Coming to this low density areas, the mass by volume is less areas. We can see that also. Compared to ferrous materials, non-ferrous metals generally lower density, making them lighter. Whereas ferrous materials density is more. That means the occupation of the in 1 cubic meter, the molecules is closely occupied. Whereas the non-ferrous metals in 1 cubic meter occupied less molecule. That's why the density is less. That's why it is easily malleable, easily can be shaped and formed with different shape what the customers wants here is. That's why some of the organizations are uh, uh, taking blocks from the organizations, non-ferrous. They take the metals in the shapes of what is called blocks, and their industry side, they will be again melt it and make it into different shapes of the kitchen utensils or other what is called hammers and all these things. Manufacturing style, if you see this, the manufacturing process of non-ferrous metals typically involves mining the ore, that is compulsory is there, extracting the metal through smelting, it is already smelting, where ore in the top percentage of the metal will be removed. Heating the ore in furnace to separate the molten metal from impurities. Impurities will be separated and metal will become in the form of molten form, or it's called smelt. You can say it is the intermediate stage between the liquid and the solid. And then refining the molten metal to remove the further impurities, and again casting like molding Like you can say the tomorrow we will discuss about the discussion of the foundry also will discuss before going to steel industry. After the further impurity is removed in the refinery, they can go to the casting. That means that will be poured in the cast metals. That means in the shaped vessels. Thereby it becomes desired shapes like knots. You can say ingots or billets. You can say the cast shaped vessels are called as ingots or billets, and then further processed through a metal methods like rolling, forging, extrusion to achieve the final desired form. That's why some of the industries are preparing, they are purchasing the blocks in the non-ferrous materials. They will take the blocks to their industry and become again what is called heating them, becoming in the molten form, and they want to cease rolling or forging into different what is called metals. They can prepare the desired form also. What are the key steps in the before non-ferrous metals from the ore? After the first mining, crushing and grinding, concentration, and the roasting and smelting, and refining and casting. These are the steps involved in the manufacture of the non-process metals. Where in the ferrous metals mining and the concentration and the only the melt formation remove the oxygen and metal privation. Whereas in this mining, crushing, and there are the various steps are there because of the various components are there in the ore, the non-ferrous. Whereas the ferrous is only metal, iron is there, other impurities can be removed very easily. Whereas non-ferrous, we can treat the depends upon the impurities consisting of by ore. The first step is to extract the ore, raw ore containing non-ferrous metal from the earth through a mining properties. As already told, keep in mind that non-ferrous materials means these five, these six or seven. And then think what is called, keep in mind and see the what is called things how to prepare. First, you extract the raw ore containing non-ferrous metal from the earth through the mining operations. Very good. Crushing and grinding. The mined ore is crushed and ground into a fine powder and to facilitate further processing. Again, in the rocks, we are going to the small pieces and crushed into the ground and become a fine powder before going to the further steps. Concentration is very important. Remove the non-ferrous materials of various type series. For example, the process like the concentration means a removal of the required non-ferrous metal from this crushed powder. That is intention. That means the concentration means the amount of the non-ferrous metal can be removed by leaving the impurities as such. That's what the concentration is. The process like froth flotation is often used to separate the desired metal or from the unwanted materials. Very important. Froth flotation means having some tank is there, having some agitator is there, and powder will be dumped into the tank and giving some cleansing agent, creating the operate the agitator. So the froth, the flotation will be formed in the tank. In the flotation, the lighter material will be coming through that foam. Therefore, the removal of impurities through that foam is also froth flotation. Different materials also there, with different process also will be there. Will be discussed in the coming slides also. Froth flotation, already know that it is a tank is there, agitation is there, revolving agitator with the cleansing agent and non-ferrous powder, grinding one. Then it will create a what is called foam. With that foam, the denser particles will be settled at the bottom, and lighter particles will be floated in the along with the foam. There that can be tapped from the tank. Therefore, the removal of unwanted materials like this. Continued here is roasting. In some cases, the concentration of ore is, one is transportation, second one is roasting. The concentration of ore is heated in the presence of oxygen to remove sulfur or other impurities through the process called roasting. Very important, roasting and smelting. The smelting is also called calcination. We can call also. Therefore, roasting is means where the
Sir, again,
ore is sulfide ore is there. In some cases, the concentration of the ore is heated in presence of oxygen to remove sulfur or other impurities from the process called.
sir, please explanation again concentration.
Yes, sir. The concentration means here is once the grinding powder is there, having the non-ferrous materials, having the impurities, still impurities are not removed. Our aim is to remove the impurities and make them the concentration of the ore. That means the removal of the non-ferrous materials is much in the concentration methods. The concentration means the removal of the actually wanted non-ferrous material is concentration. And also the same time removal of the impurities also. That is what is called the froth flotation, roasting, concentration, the smelting. These three are important methods of concentration. Somebody is repeating. Yes, sir. So the concentration is one is, got the point? Separation, that's what a process like froth flotation. You forget about the froth flotation for time. A process like is often sometimes used to separate the desired metal ore from the unwanted materials. In the powder itself, we have unwanted materials and wanted material of the non-ferrous material is also there. That's why we want to more tapped by the remove unwanted materials by getting the non-ferrous materials. There are three methods. One is concentration. In the concentration, the transportation is one method, roasting is one method, and smelting is the third method. Depending upon the ore nature, we have to select the transportation, roasting method, and the smelting method. One is transportation means that means where the material not mixing in the cleansing agent, then you add in the tank, the powder is adding in the tank, make agitator mixing. Therefore, due to that cleansing agent, the uh, float, that means foam will be created. From the foam, the impurities will be tapped. That unwanted materials will be tapped at the top. Required material at the bottom, that is ore, will be settled at the bottom. The lighter particles where the undesired particles are there, undesired dust particles or undesired impurities are there, it will come along with the foam itself. That is called froth flotation. Creating froth, that means froth means foam, and from the foam, the lighter particles will be float up the top of the tank. There it can be removed the impurities also. This is one method to select depending upon the non-fibrous, non-ferrous material depending upon the ore. Next is, suppose the transportation is not encouraging where the sulfide ore is there, in that sulfur content is more, the non-ferrous metals is there. During the lab study, we can diagnose the impurities, what kind of impurities in the ore also is there. If suppose the sulfide ore is not there, go for the froth flotation. The sulfide ore is there, go for the roasting. Roasting means heating. In some cases, the concentrated ore is heated in the presence of oxygen. You have to send the oxygen heating the powder from the crushing grinding, where it is coming from, heating with oxygen. Therefore, in the form of impurities, sulfur is there. Sulfur, sulfur dioxide, sulfur, sulfur trioxide, sulfur, sulfates. Like this, sulfur will be removed by heating in the presence of oxygen, or and also other impurities through process is called roasting. A roasting is a process is called using heating with oxygen. Here, the transportation means using with the cleansing agent, create a foam, create a what is called the froth, and take the impurities at the top and remove the impurities. This is one way. Third way is melting. Is also extraction of the metal only. Three processes are there. The primary extraction process where the ore is heated in furnace with high temperature to melt the metal, separate it from the impurities. Here is in presence of oxygen. It is in the presence of air. That's what this melting here is. That means not in the atmospheric air, the furnace, what is called RLSS, furnace oil. Like this, we have to furnace in the yes, please.
Sir, we are removing some of the metal like sulfur, as we mentioned in the metal and impurity. For removing this, can we add some impurities other, or directly for melting it is possible to remove? Is it there any chemical combination for any? We have to add any other material, any other impurities?
Yes, sir. Exactly, depending upon the which metal you are going to prepare. For example, if you go for the ore is there. For example, if you take this, depending upon the aluminum percentage, depending upon the copper percentage, depending on the lead, nickel, tin, along with the lab study, along with the aluminum, there are some other impurities are there, sir. Sulfur or any other impurities are. Depending upon the impurities, we can select the other impurities to tap that impurities, sir. Normally in the mining, the aluminum is dominant, no doubt. Along with aluminum, what are the impurities are there? That impurities can be tapped by the other impurities, or heating in the presence of oxygen, or heating in the presence of air also. What you said is 100% right. Not only the oxygen heated, not only in the presence of air, like smelting, but also we can use the other impurities to tap that material, which is not possible in the form of heating, in the form of oxygen heating. You are 100% right, sir. So depending upon the ore, or depending upon the mine nature, if the uh, transportation is not encouraging, where it is, sorry, transportation is not encouraging, go for roasting. Even roasting is also in presence of oxygen. Some of the roasting methods, only sulfur and other impurities can also be can be tapped. What you said is right, but other impurities also, other than the sulfur and other impurities which are tapped, is also we can use in the roasting form or the smelting form. Other impurities also can be tapped the material, sir. But depending upon the nature of the material, nature of the impurities are having. Lab study depends upon, sir. Okay, sir.
Okay, sir. Okay.
Thank you, sir. Thank you very much, sir. Nice question you are asking. I'm very happy. Lakshmidas Garu is a very good question, because the nature of the mine, nature of the impurities also, the oxygen heating is also not sufficient, and only the heating in the presence of air is also not sufficient, and some other impurities select the technocrats by tapping the other impurities, like other impurities along with the sulfur. Both process very busy. Very nice, sir. The smelting is primary extraction of process where the iron is heated in the presence of air. Here is missing, air is in presence of air. This is smelting. We can call it is also calcination. And whereas in presence of oxygen means it is a roasting. A simple difference is there in the small classes in the primary schools. We can explain this type of the metallurgy also. Therefore, the what the Lakshmidas Garu is telling, the other impurities along with the oxygen heating, along with the impurities also to be added to tap the unwanted materials from the non-fibrous material. Very good, sir. Now after the removal of the material or removal of the impurities, then go for the refining. Molten metal is further purified by removing the remaining impurities. You have to refine the what is called further impurities which are not taken care by the froth flotation, not by the roasting method, not by the consultation. Still, from traces are there. Gave for the electrolysis process also, where the anode cathodes will the chemical treatment. There we can tell the
Sir,
we can remove the yes, Sevakar.
sorry to disturb you.
No, sir, no, not that.
Actually, how it is useful to safety officer or safety engineer this all those information? Where it is we going to apply?
Sir, normally,
See, the safety
yes,
department is a advisory department, right? So,
yes,
so that manufacturing, you are told that that fabrications and metals, ferrous metals, all those metals, we are not engineering people. We are not going to any metallurgical people. Just we
sorry,
have a
sir.
advisory role that we are using. But how it is useful to as a safety engineer or safety, I think safety officer. I mean, so many safety officer in this forum now. But I think so, as I am and 20 years experience in my field, in oil and gas and in a construction basis and offshore also. But this type of industrial purpose, I think so. As a safety officer, it is useful material. I think so. Can you clarify
Sir,
me in this one?
exactly, definitely, sir. Thank you very much for your valuable question. Listen carefully for all people also. It's valuable by Sivaram Krishna Garu. First of all, the course content is given by the manufacturer of the year is manufacturer of basic metals, ferrous and non-metals. This is the title. Only this is the title. Next one is second one is as a safety officer. I'm very very sorry to tell you, sir. Unless otherwise, if we are not knowing the nature and behavior of the chemicals, nature and behavior of the substance which in your industry behaves, how do what is called ensure that advise this personal not to do like this, do like this. How do you give the advices if you're not knowing the consequence of the metal preparation, not in deep, not in concentration methods, not in broth rotation, not in roasting, not in smelting, in presence of oxygen, in presence of air, not necessary. But there is a method is there.
For that
Yes,
purpose,
sir.
for engineering
Yes.
people are is there. There is a protocol is there. For that purpose is a standard operating procedure is there. That what is the doing of safety officer in this case?
Exactly, sir. Coming to the point.
Sir,
Suppose
sorry to come in between. Like having
Mohammed,
basic about the subject is essential for everyone, whether he is a safety officer, whether he is an electrical engineer or mechanical engineer. If safety officer or engineer doesn't have the basic knowledge, like I don't know exactly in manufacturing in oil and gas, so we should have the basic knowledge of that components. Then only we can give the findings, or observations. Sorry to come in between. If correct me if I'm wrong.
exactly,
No. I am clarifying that. I am clarifying this matter. I am a
let me answer first.
process engineer.
As a Mohammed Karmir rightly said, I am also process engineer, as a chemical engineer. Now tell me, sir,
Yes.
Mohammed Karmir 100% right. Okay, tell me, sir,
Okay.
Krishna garu.
No. He is told that simply some knowledge is required. Okay. As a process engineer or process manager, I am not listen to the safety officer exactly. Actually, this is the main issue you are facing in a safety department. Because process manager or shift engineer or whatever it may be in industrial, for suppose some alloy material is going to the melting some in a furnace. So there is a standard procedure in SOP. So
Yeah.
SOP, based on SOP, we are going to the risk assessment or whatever it will be, hazard, hazard, whatever it may be.
Yeah.
In this case, only we are going to participate in agile workshops. Then what is the risks involved in this particular case? Then how we are not a process engineer say, as a safety officer. I told you once again. Process engineer give the process. What is the process going to the step by step? Then each activity we are going to analyze the risk and what is the existing control measures and what is the additional control measures required, we give the advice to the concerned team. But in this case, as per SOP only, they are going to the process the all material. But as a safety officer, in this case, we are going to analyze the risk only. But in this case, this material is going to main importance and main focus on the process engineering. But this process engineering not required to the as a safety officer. Safety officer looking only for what is the risk involved in that particular activity, what is the consequence of the activity, how to prevent that in case of something goes wrong, then how to protect the people. That is the scenario we are going to see. That's my point.
I'm very, very sorry to Sivaramakrishna. Maybe you're a senior having experience. I'm very sorry. I'm not denying with your what is called words. I'm very sorry to tell you, unless otherwise, if you know the fundamentals of the process or fundamentals of the behavior of the substance, how do you know the analysis, risk analysis, how to what is called
Sir, main
consequences?
person, sir, main thing, sir, what is the ferrous and what is the non-ferrous material, and what is
Yes,
their property and how they react after chemical with reaction with other materials. That is the
excellent, Bhaskar.
main things there here in this subject.
Exactly, sir. Because as a safety officer, if you're going to do the risk assessment and all these things, without having the nature of the behavior of the particular material, particular metal, particular what is called thing, how do you advise the people to go for? It's not deep, sir.
That purpose we
This
have a SOP.
SOP tells
Sir,
about the
for preparing SOP also, we should have basic
No,
knowledge.
SOP we are not going to prepare. SOP we are not
No,
going to
no,
prepare. Safety person is not eligible for preparing SOP.
I'm not saying safety person is going to prepare the SOP.
sir, Sivaramakrishna garu. Sivaramakrishna garu, okay, the process
చెప్పండి చెప్పండి.
people preparing the process people are preparing the SOP, agreed. But if you study the SOP, at least you can know the ABC also of that SOP, na? If without knowing the ABC,
So
how do you brainstorming follow up in the risk assessment? Their
I
process
think so.
department.
No, sir. Prabhakar sir, I think
Happen, sir.
this course is very fundamental base level course, right?
I'm giving the fundamentals only, sir. Only fundamentals. Because the process involves only fundamentals. Because these fundamentals should known by every safety officer. How do you
But I am
advise the
thinking
people?
it's not. No. But I am thinking it's a super special experts class, right?
No, sir,
We are
not sir.
going to as a. But in this
Sir,
case, in the very ABCD level of these fundamentals,
no,
okay, it is for upcoming new career start people. Okay, it is acceptable. But I think so. Okay, anyhow, this is already you
it
informed me.
is,
This
sir,
is the fundamental course. Okay.
is only, I'm sorry to tell you once
I
again.
think process engineering is a very vast subject. It is very fundamental. I agreed with
Exactly.
Prabhakar sir.
Yes, yes. Thank you very much, Mohammed Galar. Sivaramakrishna garu, don't think otherwise. This only fundas I am giving, sir. With great, what is called filtering of the all the things, I am giving the only filtering methods. At least to know about the fibrous and the non-ferrous. That is, sorry, ferrous and non-ferrous. Very fundas and very filtered material I am
For
giving, sir.
newcomers, it is okay. For newcomers, then they
No,
have to
sir,
know what is what.
if you are having the 20 years experience, if you are supposed to know about these fundamentals by the ferrous and non-ferrous industries, sir. Must is 100%. You should know about. Otherwise, how do you know that what is called to take this risk assessment? Process department by SOP, they are telling number of things for their safe sites. But as a safety officer, you have to condemn that process guide, process words and all by giving the risk controls more than what they are expected. If you know that intensity and seriousness and consequences better than
In
those
this forum,
people, then only.
anybody mining industry, any safety officer from mining?
Shivaji.
Yes.
Yeah, myself, Lakshmi Das, I'm also oil and gas person from last 24 years and about from 7% in